very carefully.
When the T-800 first traveled back through time to 1984, the endoskeleton of his right arm became the property of Cyberdyne Systems. Under the direction of Miles Dyson, Cyberdyne was to reverse engineer that arm. Dyson enlisted the services of Conqueror Worm to make a set of detailed blueprints of each part of the arm. These parts were later made available on the RPF. The detailed blueprints, all 131 of them, are available for download. Hi everyone, it's Ken here. When the Terminator first appeared in theaters in 1984, I was hooked, and I knew that one day I wanted one of those endoskeleton arms. But at the time, I had no experience in metalworking, and even if I had, where would I find the plans for such a thing? But recently, I ran across a blog called Life in the Uncanny Valley, where a fascinating guy named Sam had actually built the Terminator arm. Reading his site, I found that he had obtained the plans from the RPF, where Conqueror Worm had reverse-engineered a screen-accurate model of the T-800 arm. He developed 131 individual drawings, capturing every measurement on every single part, and made them freely available for download. So I downloaded them, and then began the process of modeling them in 3D using Autodesk Fusion 360. Just so you know what we're getting ourselves into, I thought I'd walk you through the CAD model of the index finger. There are quite a few parts involved in making just one finger, and of course there are 5 fingers, and then the rest of the arm that have to be constructed. I find it interesting that Conqueror Worm must have turned to a copy of Gray's Anatomy when he was doing this, because all of the parts are using the proper medical terms in their naming. He doesn't call this the index finger, it's the second phalanx. And there are metacarpals and distals and all sorts of other cool things. So you might learn some anatomy as you're modeling this. But the bottom line is there are quite a lot of parts that have to be made. Although the parts in the other fingers are similar, they are different. So pretty much each finger is a unique set of machining that has to be done. The reason for all the pulleys in the finger is so that a wire can be woven through all of the joints. If you were to pull on that wire, the finger joints would bend inward toward the palm. This generated quite a bit of discussion on the RPF thread, because although the finger can be pulled inward, there is no mechanism in this model for returning it back to its upright position. One of the suggestions was to add torsion springs in each of the finger joints, and this partially solves the problem, but there are also pistons involved that I haven't shown in this model yet, and they would have to have springs as well so that the finger could return back to its normal position. My plan going forward is to begin modifying these CAD models so that I can insert the springs that we just discussed. I then intend to make a prototype of one of the fingers so I can experiment with the various spring tensions and find that sweet spot that makes this thing work the way it's supposed to. While I'm doing that, you might want to start looking at the RPF and Life in the Uncanny Valley. They're 2 wonderful websites, and I have provided links to both of those sites in the description below the video. Once I have the prototype working, I will begin the process of making the T-800 endoskeleton. And as I do that, I will post videos that detail step by step how I go about making this. If you like this video, please click the like button. And if you'd like to follow along on this project or any of my other projects, be sure to subscribe. If you're interested in my other work, you can find it on my website at www.zeman.com. And of course, you can also find videos of my other work by scanning through my channel here at KenTunes. I will see you all soon.